Hi everyone, here's the video for AP Review number 16. AP Review 16, the last of the formal AP Review packets. Problem number 1. The derivative of f is given by f prime equals g for values of x between -4 and 0. And 5e to the negative x over 3 minus 3 for values of x that go from 0 to 4. Okay, and this is without calculator. So what else do I know? The graph is shown above. X-intercepts at -2 and 3 ln of 5/3. And that the graph of G is a semicircle, and then f of 0 equals 5. So I have an initial condition if I want to do something with f. Okay, part A. On the open interval, find all the values where f has a point of inflection. So we know f has an inflection where f prime goes from increasing to decreasing or decreasing to increasing, and that happens at which occurs at x equals -2 and x equals 0. Okay, part B. Find f of 4 and f of -4. Well, let's start with f of -4. They gave us that one first. And they've given us f prime, so I know that f of -4 minus f of 0 equals the integral from 0 to -4. Well, I don't really like that. So I'm going to pull out that negative and do -4 to 0 of f prime dx. Now, conveniently, the integral from -4 to 0 is just g. And so I want negative the integral of g from -4 to 0. Okay, and then I want to add to that 5, that's f of 0, to get f of -4. Okay, so let's find the area of this region here that we have. We're told that this is a semicircle, and our radius is 2, but we're looking for this, and there's -4. So I've got a rectangle whose area is 8, and I want to subtract from that half of a circle whose radius is 2. So 2 squared pi divided by 2. It's 8 minus 2 pi. But that's positive. Remember, I want negative. I want to flip this. So that's behind this negative sign, and then I'm adding 5. So 5 minus 8 is -3, minus a minus 2 pi is plus 2 pi. So there's f of -4. f of -4 equals 2 pi minus 3. Now, what about f of +4? Well, I'm going to do the same sort of thing. I'm going to say the integral from 0 to +4 of f prime dx equals f of 4 minus f of 0. So 5 plus the integral from 0 to 4 of 5e to the minus x over 3 dx will be f of 4. Well, okay, so I'm going to pull the constant out. And then I want the antiderivative of -x over 3. If you don't feel comfortable, do the u sub. and get negative 3 du equals dx. And so then this integral could be e to the u du with a negative 15 out in front. Now we need some u-bounds. If I plug a 0 in here, I still have 0. If I plug a 4 in here, negative 4/3. I don't like that at all. Okay, so then we would have 5 minus 15 e to the negative 4/3 minus e to the 0. That's going to be minus a minus is plus, 20 minus 15 e to the negative 4/3. Is this with calculator? It says without calculator. My notes seem to suggest it's with calculator. Okay, so that's what I've got as my answer to number 1. Maybe I'll go back and look this one up, see if we're supposed to use a calculator or not. Clearly we can do the work without a calculator. That's f of 4. Okay, part C. On the closed interval, we were looking for an absolute maximum. Okay, so a max occurs when f prime goes from f prime greater than 0 to f prime less than 0, or endpoints. So do I see any places where I go from above the x-axis to below the x-axis on the f prime graph? And yes, I do. That happens at x equals 3 ln of 5/3. Okay, so there's a critical point. And what about the endpoints? I want to consider those as well. I mean, I know when I look at this that from this point, the function f is increasing. So that's got to be a minimum because the function just goes up from there. I hit our max, and then the function is decreasing until we get to this point. So really, this is the only max. And I know that AP nowadays wants us to be doing full candidates test, but it seems a little superfluous in a situation where really I'm just given only one max to work with. So why would I need to use candidates test here? If you're feeling complacent, then say let's start that sentence with the only max occurs on f at x equals 3 ln 5/3 because to the left of this point f prime is greater than 0, to the left of x equals 3 ln 5/3, f prime is greater than 0, and to the right of x equals 3 ln 5/3, f prime is less than 0, and the endpoints are nins. Okay, so that's one approach to the problem, where we say we don't have to worry about the endpoints and we just justify the maximum. We might also want, and certainly these days I think it's a sure bet that we're going to be put in a situation where we need to do f of negative 4, f of 4, as well as f of 3 ln of 5/3, and where we actually have to compute these. Now, conveniently, we already figured these values out in the last part of the problem. And so all we have to do is evaluate this one. Ugh. So I'm going to integrate, this is bigger than 0. So I'm going to integrate from 0 to 3 ln of 5/3. This function 5e to the minus x over 3 dx. And I'm going to add 5 to that to get this. So let's see what we get in this situation. I know that, see, because they really want candidates test here. They wouldn't have had me find these explicitly in the last part if they really didn't want me to use them now. Okay, so what do I know? I know that the antiderivative of this is negative 15 integral e to the u du, where u equals negative x over 3. So if I plug a 0 in here, I still have a 0, and if I plug in 3 ln of 5/3 in here, I have negative ln of 5/3. Okay, so then I've got what? I've got 5, actually I'm going to go up here, 5 minus 15 e to the negative ln 5/3 minus e to the 0. Okay, I'm going to take this and pop it up there, and so I have ln to the negative 1 of 5/3, and that's going to be the same as e to the ln of 3/5, because that negative 1 power flips this, minus 1. E to the ln cancels, and I get 3/5 minus 1, which is negative 2/5. And so now I'm looking at 5 minus 15 times negative 2/5. Okay, these cancel, and I'm left with a 3 here, and I get 5 plus 6, or 11. And I believe 11 was greater than the 2 pi minus 3, which I got here. I mean, this is 6 minus 3, that's 3-ish. And this one, we had that wacky thing on my calculator. It turned out to be 4.046. I don't have it written down precisely. Otherwise, I could walk us through how we figure it out. I think it was 20 minus 15 e to the, and that's the part I don't remember. It would have come by plugging a 4 into the negative 4/3. Okay, so that's 20 minus 15 over e to the 4/3. Well, yeah, I don't have a good sense of that. I don't have an easy one for you. I know that e is 2.7, and this is going to be bigger than 2.7, so, but I don't know how much bigger. If it's only 3, 15 divided by 3 is 5, 20 minus 5 is 15, that should be the max. But we know it's not the max. So, yeah, maybe this is with calculator. But you've seen the candidates test as well, and that's my recommendation for these days, that you think in terms of a candidates test. Okay, problem number 2. Problem 2 says, wow, only 7 problems. This is a short one. Problem 2 says that this is definitely with calculator, and we've got f of 0 equals 5 again. F prime is e to the minus x over 4 times sine of x squared, definitely a calculator problem. And the graph of f prime is shown below. Okay. And I've got labeled 1.7724 here and 2.5066 here. There. Okay. So I must have found those with my calculator and doing second calculate 0. I think, yeah, no, I'm not trying to do that by hand. Though, wait, I guess it could. Set each of these factors equal to 0, and this first factor is never equal to 0, so I'm wondering when sine is equal to 0. Sine is equal to 0 at 0 and pi and 2 pi, but that's what x squared equals, so I want to take the square root of these, which is 0, square root of pi, and square root of 2 pi. Let's just confirm that. Square root of pi is that number, and square root of 2 pi is 2 point, oh, there's another one of my dyslexia moments, 0566. Okay, 724 and 2.0566. Great. Let me just change it on my notes. The next time someone asks me, I'll be right with you. 2.0566. All right, so how does that change things? Well, we know here in part A, use the graph of f prime to determine whether f is concave up, concave down, or neither on the interval from 1.7 to 1.9. Well, from 1.7 to 1.9, I see that f prime, since f prime is decreasing on 1.7 to 1.9, f is concave down on 1.7 to 1.9. Good, that's part A. Part B. Part B says, on the closed interval, find the value for x where f has an absolute max. Okay, so, and we're going on 0 to 3. So my graph stops here at 3. So I guess I'm thinking about this one of two ways, and I think these days we should use the candidates test. So I want to consider f of 0, which they told me was 5. I want to consider f of 1.7724. I want to consider f of 2.0566, and I want to consider f of 3. And to do this, I'm going to use f of 1.7724 minus f of 0 equals the integral from 0 to 1.7724 of f prime of x dx. So I'm going to do this integral on my calculator. I'm going to add 5 to it, and I'm going to get the value of this. So I better type this function in to f of x. So we've got e to the negative 0.25x, close parentheses, times sine of x squared. Okay, so there's our function, and I want to integrate that function from, I want to integrate y1 in terms of x from 0 to 1.7724. Okay, and then I'm going to add 5 to that, right, because I have to add the initial amount. And so I'm going to end up with 5.679. And I'm going to repeat the process, but this time with my other square root of 2 pi, second entry. And over here, square root 2 pi. You could certainly type in a decimal approximation for this, and that would be fine. And that equals, don't forget we want to add 5 to that, 5.4078. And then finally f of 3, second entry. Now we're going out to 3. We want to include that endpoint. It's not square root of 3 pi, it's just 3 don't forget we want to add 5 to this value. And I get 5.579. Okay. And the way I rationalize this is I went to the right a whole bunch. And then I stopped going to the right and I started going to the left, and that ate into how far I'd gone to the right. So by the time I'm here, I don't have all this anymore. I just have this much more than 5. And so I go a little more to the right. But I'm still, oh wait, yes I am. This is in fact bigger than that. That's strange. I was expecting something other than that answer. Let me just confirm that we have our absolute, no, see, I got absolute max at this other place. At 3, 5, I got that at 3. Oh, duh. 6 is bigger than 5, Koopa. Oh, mercy. Absolute max at x equals 1.7724, or square root of pi, according to the candidate's test. All right, there. 5 is bigger than 6. All right, that was absolute max. Let's see what they're asking next. Part C, write the equation for the tangent line of f at 2. So I need an ordered pair. I also need to know f prime of 2. Well, f prime of 2 is just plugging a 2 into the given function. So if I go over to my table feature and I plug in a 2, I get something that I can't read. I get 0.19467. So, and what if I plug a 2 into this integral? I get 5.6234. So then I think my tangent line would be y minus 5.6234 equals 0.19467 x minus 2. And look, that's not at all what I had before. That's true, but this is different. Oh, this is trig, but I am in radians. Huh. I had 0.549 before. I need to check that. Let's see. I've got the value of the point. That's good. F prime. Oh, I didn't do F prime of 2. I mean, I did F. Oh, I want F. Write the tangent line to F. So that's F of 2, 2 comma F of 2, and there's F prime of 2. And F prime is given by this function. So we want e to the negative 2 over 4 sine of 2 squared, which is e to the negative 1/2 times the sine of 4. I'm just going to check that. E to the negative 1/2 times sine of 4. Look, there it is. I don't know. How did I get that number? I'm going to go back at the table and check. So, negative 0.459. So did I have in the wrong function? E to the negative x over 4, all in parentheses, sine x squared. That should be right. Second insert multiplication sign. And then that's it. That. Let's go over here and let's plug in a 2. That's it. I hadn't actually plugged 2 in. Oh my goodness. Anyway, here's your tangent line for part C. Problem number 2. Problem number 3. Problem number 3 says, let g be a piecewise linear function defined by negative 2 pi to 2 pi. We've been given a graph. That's negative 2 pi, that's 2 pi, and that's 4 pi. Okay, and this is a graph of g. This is g of x. This equation is 1x plus 2 pi, and this goes down 2 pi and over 4 pi, so it's negative 1 half x plus 2 pi. Okay, so those are my pieces. Now, what am I supposed to do? Part A, find the integral from negative 2 pi to 4 pi of f of x dx. Well, that's going to be the integral from negative 2 pi to 4 pi of g of x minus the integral from negative 2 pi to 4 pi of cosine x over 2 dx. Okay, this is without calculator, so I need to put my thinking hat on. The integral from negative 2 pi to 4 pi of g is the integral of this picture, which is just the area of this triangle. The base is 6 pi, the height is 2 pi. I get 1 half 6 pi times 2 pi, or 6 pi squared. Now, what about this? I need to do this integral. Well, again, if I'm not comfortable with it, I could say u is x over 2, and therefore 2 du was dx. So I could rewrite this as 2 cosine u. Let's plug in a u-bound. Negative 2 pi divided by 2 is negative pi. And if I plug in a 4 pi divided by 2 is 2 pi. So the antiderivative of cosine is sine u evaluated negative pi to 2 pi. Well, the sine of pi is negative pi is 0, and the sine of 2 pi is 0. So I feel like I'm just getting 6 pi squared here for this one. 6 pi squared. Yes, exactly 6 pi squared. Because this turns out to be 0. Okay, so that's part A. Yes, and show the computations that led to our answer. 6 pi squared, 0 minus 0 minus 6 pi squared. Good. It's good to have that all worked out. So there's part A for number 3. What about part B? Part B says find the values on the open interval for which f has a critical point. F has a critical point when f prime equals 0. So let's look at the way our f function was defined again. It was defined as g minus cosine x over 2. So f prime is going to be g prime, and the derivative of negative cosine is positive sine x over 2 times the derivative of the inside, 1 half. And I'm wondering when f prime is equal to 0, plus 1 half sine x over 2. Now, you may recall that I wrote the equations of the piecewise g of x, and I said that g would be x plus 2 pi, and I said negative 1 half x plus 2 pi for x less than 0 and for x greater than 0. Okay, so what I need to think about is breaking this problem into two pieces. I'm going to deal with this piece first and say, okay, g prime equals 1 for x values less than 0 and negative 1 half for x values greater than 0. I'm going to split this problem up into two intervals. The first interval where g prime is equal to 1. So 0 equals 1 plus 1 half sine x over 2. Or negative 2 equals sine x over 2. Right? Because I subtract 1 and I multiply by 2. But wait a minute, sine can never be equal to negative 2. So never. Now, what about the other piece? 0 equals negative 1 half plus 1/2 sine x over 2. So I add 1/2 to both sides, and that gives me 1/2 equals 1/2 sine x over 2. I divide both sides by 1/2, and now I've got 1 equals that. When does sine equal 1? Sine equals 1 at pi over 2. So pi over 2 equals x over 2. I multiply both sides by that, and I get x equals pi. X equals pi is a critical point. Did I do it right? I did it right. Yay! Okay, so that's how we need to do that problem. This is never equal to -2, so that doesn't produce any critical points. But over here we get critical points when g prime plus the derivative of negative cosine x over 2 equals 0, and that's when this equals 1. Okay. Part C. Now we're given an h of x function. H of x is defined as the integral from 0 to 3x of g of t dt. And we're asked to find h prime of negative pi over 3. Well, h prime is all about taking the derivative of this integral. So this comes down in here, and I get g of 3x times the derivative of 3x, which is 3. And I want to know h prime of negative pi over 3. And so that's going to be g of 3 times negative pi over 3 times 3. This is g of negative pi times 3. Okay, the graph of g is provided to us, and at negative pi, the value is pi times 3. You know, if you're not sure of that, remember I wrote the g of x function as 1x plus 2 pi, and if we plug in a negative pi and add 2 pi, we get pi for g of pi. Okay, so 3 pi is the value of that. Great, there's part C done. And we move on to problem number 4. Problem number 4 says graph of f prime is shown, okay, on the interval negative 1 to 5. Yes, it is. F is twice differentiable. There are horizontal tangents at 1 and 3. And f of 2 equals 6. Okay, so part A, find the x-coordinate of each point of inflection on f. F has inflection points at x equals 1 and x equals 3 because f prime goes from increasing to decreasing or decreasing to increasing at these points. Done. Part A. Part B. Part B says, at what value of x does f obtain its minimum value on the closed interval from negative 1 to 5? So, you know, just talking through this, because f prime is negative, 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 negative until this point, I'm thinking that's going to be my absolute min right there. And this endpoint is a maximum because from this point, f decreases, and f increases until we get to x equals 5, and so that's also a maximum. So clearly, back in the old days, we didn't really need to do a candidates test because we were given only one max to worry about. There's only, one min to worry about in this problem, and that occurs at 4. But these days, they really want us to consider candidates test, which means we'd have to have f of negative 1, we'd need f of 1, we need f of 4, and we need f of 5. But do I have enough information to figure those out? Well, I don't actually have a function. nor do I actually have the areas. So I don't feel like I can actually do a candidates test here to integrate things. All I feel like I can say is be the only min, and therefore the absolute min occurs at x equals 4. I might add parenthetically, no sign change at x equals 1 means neither a min nor a max, and the endpoints are maxes. Occurs at 4 because to the left of x equals 4, f prime is less than 0, and to the right of x equals 4, f prime is greater than 0. Okay, there's for part B. And finally, for part C says g equals x f of x. Write the equation for the line tangent to the graph of g at 2. So I need g of 2, which is going to be 2 times f of 2. F of 2 equals negative 1, so 2 times negative 1, or negative 2. So I have an ordered pair, 2, negative 2. Now I need g prime of 2. So for that, I need g prime of x, which requires the product rule, 1 times f of x plus x times f prime of x. And then I'll stuff in my 2, f of 2 plus 2 times f prime of 2. Okay, f prime of 2. F prime of 2. Oh, I made a mistake here. F of 2 is 6. F of 2 is 6. So this is 12. F prime is the graph given. F prime of 2 is negative 1 times 2 plus f of 2 is 6. And so I get 4. Okay, so g prime of 2 is 4, and g of 2 is 12. I think I got that right. Let me just confirm with my notes. G prime, part C. G prime of 2, I'm sorry, I'm on problem 4. There we go. G prime of 2 is 4, good, and g of 2 is 12, yes. So then my tangent line is going to be y minus 12 equals 4, x minus 2, and there's part C. Part C for number 4. Okay, we just have 5, 6, and 7 left. Problem number 5 looks like this. It's this very interesting kind of M thing. All right, let's take a look at it. It says g is the function given by the integral of that graph. Therefore, g prime equals that graph. Okay, how do I know that? Because if I integrate from 0 to x f of t dt, and I think about, oh, I want g prime, well, I better take the derivative of both sides. And so this gives me that, and then when I take the derivative of the integral, this comes down here, and I just have f of x. Okay, so g prime is this graph. This graph is g prime. All right, what do they ask us here in part A? Find g of 4, g prime of 4, g double prime of 4. Okay, so g of 4, according to the definition of g, is the integral from 0 to 4 of f of t dt. Well, the integral from 0 to 4 is 1/2 negative 2 times 1 plus this trapezoid area 1/2 a height of 2 times base 1, 4 minus 1 is 3, plus base 2, 3 minus 2 is 1. And so what do I get? I get negative 1 plus 4, or 3. G of 4 equals 3. I like G of 4 equals 3. Now, G prime of 4 equals F of 4. We've already established that. And F of 4 equals 0. G double prime of 4 is F prime of 4, or the slope of F at 4. Well, I notice that I go down 4 and over 2. Down 4 and over 2. So I get negative 2 for G double prime of 4. Okay, there's part A. And part B says, does G have a relative min or max, or neither, at x equals 1? Okay, so in order to answer the question about G having a max, a min, at x equals 1, I want to look at G prime, and I want to see what's happening on G prime at 1. Well, we know G prime is equal to F, and at 1, G prime equals F goes from negative to positive. And so there is a min on G at x equals 1, because to the left of x equals 1, G prime equals F is less than 0, and to the right of x equals 1, G prime equals F is greater than 0. And did we have to justify it? Yes, we did. I'm glad, because otherwise I would have felt silly justifying something that didn't need to be justified. Okay, part C. Suppose F is defined for all real numbers x and is periodic with a length of 5. Look, I start at 0, I go through one of these, and I finish at 5. Look, I start at negative 5, I go through one of those, and I end up at 0. The period, the distance from here to here, is 0 before we repeat. So every 5 units, this thing goes through another complete cycle. Okay, so we know that G of 5 equals 2. And we find G of 10. Okay, so since the period is 5 and the distance between these is 5, G of 10 is also 2. Yeah? So that's what, oh, this is a graph of F. F has a period of 5. It's good to read, isn't it? Yes, F has a period of 5. Okay, so we know that G prime equals F. There we go. So G of 10 minus G of 5 equals the integral from 5 to 10 of G prime dx, which is the integral from 5 to 10 of F dx. So the integral from 5 to 10, well, I don't see the graph of 5 to 10 here, but I know the graph from 5 to 10 is just going to be like the graph from negative 5 to 0, or the graph from 0 to 5. So let's find the integral here. Now, be careful. The integral here is this below the axis, this below the axis, and this above the axis. Now note, this negative bit and this positive bit cancel each other out. So all we're left with is this area that goes from 2 to 3 with a height of 2. So this integral is going to be 2. So I get G of 10 equals G of 5 plus 2. And G of 5 is 2. Do I know that? How do I know G of 5 is 2? Did I already figure that out? I did already figure it. No, G of 4 is what I figured out. How do I figure out g of 5? G of 5, oh, is 2. Okay, so 2 plus 2 equals 4 for g of 10. How did I do? Did I do that? Yes, that's great. G of 10 is 4. Okay, so we've done that part. Now it says, write the equation for the line tangent to the graph at x equals 108. 108? So how many units of 5 will go into that? I can divide 5 into that. 5 into 108. 21 times with a remainder of 105, a remainder of 3. So it's as though I went through this cycle 21 full times, and then I counted 1, 2, 3. So I think f of 108 equals, what was the y value here? 2. All right, now, in order to write the equation of the tangent line to g, wasn't it? Yes. I need g of 108, and I need g prime of 108. Well, luckily, g prime of 108 is the same as f of 108, and we figured out that that was 2. So the only thing we need to find is g of 108. All right, well, let's figure out g of 108. So g of 108 minus g of 5 equals the integral from 5 to 108 of this graph. Now, from 5 to 105, we're just going to be repeating the same shape over and over and over 21 times. So I have 21 times, and what was the area when we took out these negative bits with these positive bits? We were left with an area of 2. So I have 21 times 2 plus, that only gets me through 21 complete cycles. Then I want to go 1, 2, 3 more. So what's the integral from 0 to 3? This negative and this positive cancel each other out, and I have another 2, plus 2. And so I get 44 here. Woof. So that's going to be, and in fact, you might want to write this out as the integral from, I did 21 times, so I started at 0. Okay, that's the integral from 0 to 105 of f dx plus the integral from 105 to 108 of f of x dx. This was 21 times 2 plus this was negative 1 plus 1 plus 2, and so we ended up with a total of 44. All right, so my tangent line equation then is going to be y minus 44 equals 2x minus 108. And there's our tangent line equation. I don't think you need to take it any further than that. Do they ask us to do anything else here? No, write the equation for. Okay, there's 5c. All right, 6. 6 says f equals the integral from 0 to 3x of square root of 4 plus t squared dt. And g equals the f of sine x. Ew. All right, I can't wait for the mischief that comes for us now. Find f prime of x. Okay, so when I take the derivative of that integral, I get the square root of 4 plus 9x squared times the derivative of that inside function, so times 3. 3 square root 4 plus 9x squared. Make sure you square that 3x, not just the x, but the 3 as well, has to be squared. That's why I have 9x squared there. What else are we supposed to find? We're supposed to find g prime. Well, g prime is going to be f prime, leave the inside alone, times the derivative of sine, which is cosine. So f prime is this, and I want to plug a sine in there. So 3 square root 4 plus 9 sine squared x times cosine x. That would be my answer to 6a. 6a. We've got square root 3 cosine 4 9. Yes, very good. Okay, part B. Write the equation of the line tangent to g at pi. So g of pi and g prime of pi. So g of pi, plug a pi in here. The sine of pi is 0. Sine of pi is 0. F of 0. F of 0. Well, here's f. F of 0 is the integral from 0 to 0. Well, the integral from 0 to 0 is 0. So f of 0 is 0. So g of pi is 0. Now, what about g prime of pi? I have to plug in my pi here. That's f prime of 0. Here's f prime. I plug a 0 in here. I get square root of 4, which is 2 times 3, or 6, times cosine of pi, which is negative 1. So now I've got negative 6. Okay, so we've got negative 6 for g prime of pi, and g of pi equals 0. So then y minus 0 equals negative 6. X minus pi is my tangent line. And I move on. Part C. Part C says, write but do not evaluate an integral expression that represents the maximum value of g on the interval from 0 to pi. The maximum value of g. Well, remember we said that g of x was equal to f of sine x. And if I want a max, then I want the derivative, which is f prime of sine x times the derivative of the inside function. And I want to know when, and that's equal to 3 square root 4 plus 9x squared times cosine x equals 0. And we were asked here for represents the maximum of g. So I wonder when this equals 0. Well, this equals 0 never, right? Because this is always going to be positive, even if I put a negative here. And if I put a 0 here, this is always positive. So this will never be equal to 0. This is not equal to 0. So I just have to worry about cosine being equal to 0. And that happens at pi over 2 and 3 pi over 2. Okay, so I have some critical values, and do they explain where? On 0 to pi. This is bigger than pi, so I can discard that. So I've got one critical value, pi over 2. Wait, that represents the maximum value. Oh, well, let's just confirm that this is a max. 0 and pi. So if I plug in a 0 into here, into g prime, if I plug in a 0, I get 6 times 1, or 6, and that's positive. If I plug in a pi, I get a positive times negative 1, and that's a negative. So I definitely have a max at x equals pi over 2. However, read carefully. They want the maximum value. They want to know what g of pi over 2 is. So, to find g of pi over 2, g of pi over 2 equals f of sine of pi over 2. And we know that f is this integral. So we want the integral from 0 to this is our input. Our input goes here. So 3 sine of pi over 2. And what goes here is just that stuff. Square root 4 plus t squared dt. That equals g of pi over 2. Integral from, and sine of pi over 2 is 1. And so really we could tidy this up. Square root 4 plus t squared dt. Okay, that would work. We don't have to actually figure out what that value is, do we? Does it say find the maximum value? Right, but do not evaluate. Stop here. So either one of these, well, no, you better tidy that up. Let's say this one. And don't box in your answers, because then the reader can't say, oh, they restarted, or it's a parallel solution. Okay, there's problem number 6. And our last problem in AP 16 is consider the differentiable function f, the domain of all positive real numbers. It is known, in the places of knowing, it is known that f prime is 4 minus x times x to the minus 3 for x greater than 0. Find the x-coordinate of the critical point. There's only one, and it's at 4. So how did I know that so fast? Well, here's my f prime. And f prime is equal to 0. F prime is equal to 0 when the top is equal to 0. And f prime is undefined, also a critical point, when x equals 0. But they say x is bigger than 0. So we don't have to worry about the undefined derivative. Okay, so we've got a critical point. Find the x-coordinate of the critical point. Good. Determine whether this point is a relative min-max or neither. This is an opportunity for me to use the second derivative test. I'm going to take the derivative of my f prime using the product rule. I'm going to have negative 1 times x to the minus 3 plus 4 minus x times negative 3 x to the minus 4. I'm going to factor out the smaller of these powers and the negative sign, negative x to the negative 4th. Now, when I factor a negative out, I'm going to be left with x to the 1. And then here, I'm left with, this goes away, I took out the negative, plus 12 minus 3x, because I took out the negative. Okay, so now I've got negative 2x minus 12, no, plus 12 on top, and a negative and next to the 4th. So here's f double prime. And I want to know f double prime at 4. I probably shouldn't have distributed and combined like terms. It would have been much easier. Because 4 times 3 is 12, 12 minus 12 is 0, plus 4 is 4. So I have 4 on top, and I have 256 on the bottom, but don't forget that negative out in front. Because f double prime of 4 is less than 0, we know that our original function is concave down, and therefore we have a max. So, do we have to write a justification here? Yes, we do. Okay. Since f prime of 4 equals 0 and f double prime of 4 is less than 0, there is a max at x equals 4 on f of x. Done. That's all the justification I need for the second derivative test. It sort of makes up for having to actually find that second derivative and plug a number into it. Okay, that's part A. Part A. Part B, find the intervals on which f is concave down. F is concave down when f double prime is less than 0. Oh, I wish I hadn't erased that derivative. All right, so yeah, sometimes it's good to write things down. I did on another piece of paper called my notes. 7. Yes, I do have f double prime. F double prime equals 2x minus 12 over x to the 4th. Okay, so what critical points do I have here? Remember, x is got to be greater than 0 in this problem, so I don't have to worry about my undefined derivative. I set the top equal to 0, 2x minus 12 equals 0. That's finding f double prime equals 0, and so that happens at x equals 6. So plug in 6, I have f double prime, I put in a 0, I get negative, I put in a 10, I get 20 minus 12, that's positive, and so I see a sign change in f double prime, but I want to know when this thing is concave down. F is concave down, so I say f is concave down on 0 to 6 because f double prime is less than 0 on 0 to 6. Okay, and that was part B. And then finally part C for number 7. Part C says, given that f of 1 equals 2, determine f. Okay, well, I know that the integral of f prime will give me f plus c. So let's find the antiderivative of this function, which was 4 minus x times x to the minus 3 dx. Now, yeah, I'm not keen to do it this way. So we could think of this as the integral of 4 minus x over x to the third, but I'm still not keen to do it this way. Instead, what I want to do is split this up into 4 over x to the third minus x over x to the third dx. And then that's going to be 4x to the minus 3 minus x to the minus 2, right? Because this cancels one of those, and then I flip this up, dx. The antiderivative of this, not the derivative of this, the antiderivative of this. I have to add 1 to this. So this is going to be 4x to the minus 2 over minus 2 minus, I add 1 to this, x to the negative 1 over negative 1. Okay, negative, negative, that makes positive. And so this becomes a negative 2. Negative 2 over x squared plus 1 over x plus c. And now I use my initial condition. I plug in a 1. I plug in a 1. I get minus 2 plus 1 is 1 plus c should equal 2. So I'm going to use that initial condition. I've just run out of some space, so let's make a little more space and say that 2 equals negative 2 over 1 plus 1 over 1 plus c. So 2 equals negative 1 plus c. C equals 3. And so then our function is negative 2 over x squared plus 1 over x plus 3. Ta-da! We're done with AP Review Packet 16. I hope this was helpful. I really expect questions like this to show up, a question like this to show up on our free response this year. So do plan on it. Have a wonderful day, everyone.